Unit 6. We're starting out with quadratic functions. We are going to factor. We are going to substitute. We are going to evaluate the quadratic functions. We are going to use our calculator. But we do want to start thinking about these quadratics and anticipating what is going to happen. Our quadratic function, f of x, equals ax squared plus bx plus c. So when I refer to the a term, or the b term, or the c term, that is where they will be located. Sometimes you will not have a b term. Sometimes you will not have a c term. You will always have an a term when it's a quadratic. The first part, the substitution, where it says without using your calculator, you can always use your calculator. Substituting in the values. You have got to make sure you can substitute these values in correctly. So a, where it has f of x equals x squared, f of negative 3, f of 5. You can see that the negative 3 is in the place of the x. So wherever an x is, that's where you will plug in negative 3. Now I do not want you simply plugging in negative 3 squared. If you do not put it in parentheses, it will give you an incorrect output value. So we are going to use our such that. So we have x squared such that x equals negative 3. Enter. There's your output value, 9. The next one is 5. Bring it down. Put in 5, not 55. And you get 25. So those two values are 9 and 25. Now we have done this before. I know you've done it in Algebra 1. I know we've already done it this year. So these two right here, B and C, when you come in tomorrow, I am going to have a note card. I want the answer to G2, G negative 1, H negative 2, and H3. That is going to be handed in for a grade. So those four output values will be handed in at the beginning of class tomorrow. Make sure you are prepared. Graphing. They're parabolas, x squared. They open up, they open down, depending on the leading coefficient. Now, the domain, you could have a restricted domain. So in this case, you have a restricted domain. So it's the simplest of all quadratic functions, y equals x squared. They want you to create the table of values and plot this function over the domain. Not out of line for them to ask. You can go right to your graph page. A little late with the snap. And just plug in x squared. There's your x squared. Enter. That's what the parabola looks like. Control T. I think they wanted negative 3 to 3. So there you have it. There's your input. There's your output. So to fill in the table from negative 3 to 3, we have 9, 4, 1, 0, 1, 4, 9. This should always happen in a parabola. Once you find the vertex is the turning point. Maybe they ask for the max point, maybe they ask for the min point. These values should match up. Okay, and I want you to sketch the graph on the grid to the right. So you have 0, 0, 1, 1, negative 1, 1, and then the 2's bring me up to 4, 3, 4, and 4, 5, 6, 7, 8, 9. The 3's bring me up to 9. Now it's a restricted domain. Therefore, you do not have arrows. You do not go through those points. This tells me the restricted domain right there. Negative 3 less than or equal to x less than or equal to 3. State the coordinates of the turning point. The turning point is the lowest point in this case because it opens up. So it is 0, 0. State the equation of this parabola's axis of symmetry. The axis of symmetry is the x value of the turning point. So you just simply say whatever x equals at the turning point. X equals 0. X equals 0. Over what interval is this function increasing? So you always read it from left to right. So left to right, this is going down, down, down. So this is decreasing to the turning point, and then it will start increasing. So this function is increasing. Again, it's restricted, so it's from 0 to 3, or you can have without the equal sign on the 0 because that is a turning point. Next part, consider the quadratic function, negative x squared plus 6x plus 5. Using the table on your graphing calculator, determine the turning point. So calculator, we are going to graph another one. So this is negative x squared plus 6x plus 5. Graph it. You can see it's outside the scope of your window. If you want to zoom out, you can. Menu, 4, zoom out, 4, center, go to the center, enter, and you zoom out. Okay? We want the turning point. So menu, let's analyze the graph. And in this case, it's a maximum, not a minimum. So the maximum is 3. Lower bound, anywhere to the left, enter. Upper bound, there you go. And you see it zooms out again for you. So using the table and your graph to determine the turning point is 314. So 314, it's an ordered pair. What is the range of this quadratic? The domain, remember, are your x values. The range are your y values. Now, this is not a restricted domain. Therefore, it will not be a restricted range. Since my highest y value is 14, the range of this quadratic is y is less than or equal to 14. Or you can have negative infinity to 14. 14 has to have a bracket because it is inclusive. Now, graphing the function. Graphing the function, again, you have to graph the vertex. So it's at 3 and 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14. So 3, 14 right there. Okay, that is the key. Then when you go back to look at your table, 2 and 4 should be the same, and they are at 12. 1 and 5 will be the same, and they're at 10. So 1, 2, 3, here and here. And then 0, the y-intercept's the easiest because you just plug in 0, you get 5. So at 0, 1, 2, 3, 4, 5. And then over here at 6, you're at 5. They have a couple other graphs, but that's okay. As long as I see 2 or 3 on either side of the vertex, and I can't see this because I have a shadow. And that's a sketch. That's a graph of the function. Make sure at the vertex it's a curve, not a point, because then that would be an absolute value. Why does this parabola open downward as opposed to the y equals x squared, which open upward? Because my a term is less than 0. So if I have a negative, it opens down. Between what two consecutive integers does the larger solution of the equation lie? Okay, so this right here, a little tricky because I stopped at the coordinate 1, 2, 3, 4, 6, 5. So we look here. And in order to figure that out, we go to our table. Control T. And we are trying to find, okay, you could see between 6 and 7, it goes from positive to negative. The only way it can go from positive to negative is crossing the x-axis. So since it crosses the x-axis between 6 and 7, that answers the question. Between what two consecutive integers does a larger solution lie? Exercise 4. A sketch of the quadratic function is shown below, marked with points and its intercepts and turning point. Using labels or graphs on your calculator, determine the coordinates for each of the points. So we just have to put this right in our calculator. So back to the calculator again and plug in x squared. Okay, I had to pause that. I didn't think you wanted to hear the announcement. So I plugged in my x squared minus 11x minus 26. And I'm going to graph it. Now clearly you can see it is outside the scope of the window. So again, if you want to zoom out, 4, go to the center, zoom out. Okay, there it is. All right. Now that's most of it. You can zoom out again if you want to see the entire graph. Okay, but you don't have to, because once you find the values, it will zoom out for you. Now your x-intercepts. You have one on the left of the y-axis, one on the right. Control T, find my x-intercepts. There's one right there, negative 2, 0. Okay, let's see if we can find the other one. Okay, without being too, oh, there it is, 13, 0. Okay, so my x-intercepts, the zeros, are negative 2, 0 and 13, 0. Sometimes they are not the easiest to find, the x-intercepts. So if you go back to your graph, remove the table, and we can find menu, analyze graph, the zeros. So there, oh, gotta make sure you're to the left of the furthest one. Lower bound, upper bound, so he gives a 0, get that finger out of the way. And you can see it's negative 2, 0. And then you can find the other one as well, 0. Oh, what did I do? Actions, okay, I forgot to do. Menu, analyze graph, there's your 0. Lower bound, upper bound, and there's your 13, 0. Okay, so you can use that. The y-intercept. The y-intercept is the easiest value to find because the y-intercept has an x value of 0. Therefore, you put 0 in for x, 0 in for x. It is always the constant. So you have 0, negative 26. The turning point. Back to your graph. The turning point. Menu. Analyze graph. This is going to be a minimum point. 2. Lower bound will come all the way to the right. So pull it over here to the left. Enter. It doesn't matter how far you are. Okay, look, it says minimum right there. Enter, enter, it'll zoom out for you. So there you have your minimum or your turning point, which is 5.5 and negative 56.3. That's your turning point. Over what interval is this function positive? So we are looking for values that are above the x-axis. So I'm looking at this part of the graph and this part of the graph. That is where the function is positive. So in order for it to be positive, my x value is less than negative 2, or my x value is greater than 13. So that's it for lesson 1. Hopefully it was a review. Hopefully it was easily to understand. Make sure you have those 4 answers to put on a note card as soon as you come into class tomorrow. And I'll see you later.